Inferential procedures are based on two major categories. One of them is called estimation process or estimation of parameters. And second is called estimation of parameters. Second is called testing of hypothesis. Number one, number two, testing of hypothesis. Initially, in the previous chapter, we have studied how the parameters are estimated, testing of hypothesis. How the parameters are estimated, two segments were discussed: point estimation and interval estimation or confidence interval. In simple, we can say it is a confidence interval, CI. CI is a confidence interval, which is an interval estimation. If the population is there and all elements of population, we do not have the concept, we do not have conducted the census, but we are interested in this parameter. If this parameter is completely unknown and we are interested to obtain an estimate, then procedure number 1 will be used. So what we have to do in point estimation, we have to select a random sample and then the mean of this random sample is calculated. That sample mean will be used as a point estimate of the population parameter. So if the population is completely unknown and we do not have the all observations in my population, census was not conducted, it is impractical or not feasible for us to conduct the census. So we have to select a random sample. And from that random sample, we have to calculate statistic. From that statistics will be used as an estimate of population parameter. In contrast to the estimation in hypothesis testing, we have a predefined knowledge about the population parameter. We are not saying that the population is completely unknown as we were saying in estimation. Here, some predefined knowledge we have. Suppose someone is saying that the life of product is average life of product in a compressor of refrigerator is 5 years. This statement is called hypothesis. From where we get this information? This information, company may get this information by a previous survey or is a previous estimate. Someone previously estimated. So what is the knowledge in this statement? This is not mu naught. This is basically H naught. H naught is the null hypothesis. In this statement, what we are saying that we have a product of refrigerators, and instead of assessing the life of all produced refrigerators, we have selected a random sample of 10 refrigerators. Out of these 10 refrigerators, we have computed the sample mean X bar. And what we are going to say with the help of testing of hypothesis, someone has estimated that the sample mean was 5 years. We are interested to check after 1 year or 2 years whether this mean of 5 years is still valid for the population or not. So we have to form a hypothesis which is called null hypothesis, and we have to form another hypothesis which is called an alternate hypothesis. Company is interested to prove that the average life of the refrigerator compressor is more than 5 years. The company claim is what? Company claim is the average life of the refrigerator compressor is more than 5 years. So this is the statement in which the company is interested to prove. So H naught is the null hypothesis, H1 is the alternate hypothesis. Entire procedure of testing of these hypotheses is to be discussed in this chapter. This is chapter number 9 in this book. So, starting by the definition of hypothesis, a hypothesis is a claim or a statement or a narration about the population parameter. It is a sentence in which the value of the population parameter is described. This statement is to be written into the two forms. One is called null hypothesis, represented by H naught. Another is called alternate hypothesis, represented by HA or H1. So HA is what? Alternate hypothesis. Sometimes I will use the term H1 for representing the alternate hypothesis. The null hypothesis, in which the parameter is stated, we have to check the validity of this statement, whether the statement is true or it is not true. So, in simple, a hypothesis is a claim in which the population parameter is stated. The validity of this claim is under question. Means we are not certain that this claim is valid or not valid. We have to check the validity of this claim. For example, the average income of all Pakistanis is 13,000 per month. We can write down this statement as H naught, null hypothesis, and the average income is average income of all Pakistanis is a population mean. So what we are saying that in this statement, the average income of all Pakistanis is 13,000 rupees per month. This is the null hypothesis. In another statement, there is not necessary that in all the hypotheses we are describing the population parameter mu. We may describe the other parameters too. For example, in part B, 60% smokers in population get lung cancer. Another parameter is described here in this statement, and that statement is what? H naught, and the population parameter proportion capital P, because we have to write down the parameter in hypothesis. P is equal to 0.6. This is the null hypothesis. On the in our population, 60% smokers get lung cancer. It means the probability of getting the lung cancer of smokers is 0.6. This is the null hypothesis. Here the parameter proportion is stated, neither the mean. We may add the few more examples of the hypothesis test. For example, the average bandwidth needed at a specific server is 2 terabyte, 2 TB. So this is one statement in which the load on the average load on the server is stated. So this is the null hypothesis. So we may have the several examples of the null hypothesis, but three of them are here. Null hypothesis to be tested, and it is represented by H naught. Alternate hypothesis is the contrast hypothesis of H naught. If we are saying that the average is less than 50,000, then in alternate hypothesis we have greater than 50,000. So it is a contrast statement. Like generally we use is equal to sign in the null hypothesis, and we did not use the is equal to sign in alternate hypothesis. Generally, alternate hypothesis may be either in is defined as an equality or greater than. In alternate hypothesis is defined either by not equal to or greater than or less than. So we may have three symbols in alternate hypothesis, either not equal to or greater than or less than. While in null hypothesis, we generally have an equality. The equality should be there, and here we have an inequality, either and not equal to, greater than, or equal to. This is an example of null hypothesis. Mu naught. Mu naught is the value of the stated problem. Whatever the value of the parameter described in the null hypothesis or in the claim, that is represented by mu naught. So in my three examples, the first example, the average income is 13,000. The mu naught is 13,000. In the second example, the proportion was 0.6. So I can write down as p naught, not mu naught, because that is not mean, that is a proportion. The proportion will be p naught we are representing. And in the third example, I gave you the 2 terabyte average load on the server. So mu naught is 2 terabyte is the case. A alternate hypothesis should reflect the purpose of the hypothesis test. Researcher is interested in alternate hypothesis to prove, because statement of research is enclosed in alternate hypothesis. The researchers have a high interest in alternate hypothesis in contrast of null hypothesis, because null is saying that it is equal to, but researcher is interested to prove it that this product is better than that. Average life is more than 5 years, neither it is 5 years. The researcher is to prove average life of refrigerator is H1. H1 is what? Average life of refrigerator is greater than 5 years. The researcher has to prove that whether life of compressor of refrigerator is more than 5 years. So our interest is in alternate hypothesis to prove. One tail and two tail test, depending on the alternate hypothesis. If our alternate hypothesis having a not equal to sign, so we have a two tail test. Two tail tests are generally represented by two-sided test. We can also say a two-sided test for it. Alpha, that is the shaded region. Alpha is the probability of shaded region. That alpha is to be splitted or segmented into two parts. One of them is known as alpha by 2, other is called alpha by 2. So if your alpha by 2 is this, alpha by 2 is this is known as level of significance, as we use this term into the previous lecture. This is 1 minus alpha, or we can call it as level of confidence. So this is the level of confidence, this is the level of significance. If your alternate hypothesis have a not equal to sign, your level of significance is to be bifurcated into the two segments. That is why it is called two-tailed test. If in your alternate hypothesis we have a less than sign, then in that case we use the left tail test. Suppose our alternate hypothesis is this. In this alternate hypothesis we have less than sign. Average probability is less than 0.6. Probability of getting the lung cancer is less than 0.6. This is alternate hypothesis, which is the claim by a researcher. So that is to be proved. If you have a less than sign in your alternate hypothesis, we have to use the left tail test. Left tail test is what? You have to use entire alpha on the left side. This is your alpha, and entire alpha will be used on the left side, and this is 1 minus alpha, which is level of confidence. The level of significance alpha is to be considered at a time on one side, which is left side. If we have a less than sign, you can treat this less than sign as a arrow, and this arrow is indicating that we have to consider only the left segment of the shaded region. Similarly, if we have a right tail test, depending on the alternate hypothesis, if in your alternate hypothesis we have, as I was saying, that average life of refrigerator compressor is more than 5 years. This is the researchers claim. The average life is more than 5 years. So if the alternate hypothesis H1 or HA containing a greater than symbol, so we have to use a right tail test. Right tail test will be what? You have to bifurcate the entire region into two segments. One segment is on the right side. This is called alpha, entire alpha. 5%. Generally, it is taken as 5%. This is 1 minus alpha. If alpha is 5%, then 1 minus alpha will be assumed as a 95% region. So this is the basis of hypothesis testing, where we will use this left tail, right tail, and two tail test. You will see it later on in this presentation. This is example number 9.1. Quality assurance. Company produces bags of chips. This contains 450-gram bag. The average of product size is 450 gram. And it may vary slightly from 454 gram from one bag to another. The company insists that the mean net weight of bag is, the company's claim is what? Company's claim is the average weight is 454 gram. As a part of its program, the quality assurance department periodically performs a hypothesis test to decide whether the packaging machine is working fine or not. So it is to be tested. The null hypothesis, you have to describe the null hypothesis. Your null hypothesis will be average weight is 454 gram. And what statement the quality assurance department is interested in? Whether the machine is working fine or not. The alternate hypothesis will be what? Assumption. The assumption is H1. This is not H0. This is H1. H1. Mu is not equal to, if the machine is not working fine, then this will be either less than 454 gram. We can say that the machine is not working fine. If it is producing more than 450 gram, it is a loss for the company. Then it is against the statement of 450 gram. So there are the two possibilities in alternate hypothesis. In this example, weight is not 454 gram, means machine is not working fine. Now in part C, you have to classify as a two tail, left tail, right tail test. As I told you, if you have a less than sign in alternate hypothesis, left tail is used. This is the case. If you have a greater than sign in your alternate hypothesis, you have to use right tail test. This is the case. And you have a not equal to sign. If you have a not equal to sign like we have in this example, so we have to use the two tail test. In a two tail test, the half of the alpha will be considered on the left side, alpha by 2, and the remaining half of the alpha will be considered on the right side. It is alpha by 2, and the middle area is 1 minus alpha, which is level of confidence. So if you have to classify here, in my case, I have to use a two-tailed test. The reason is we have a not equal to sign in our alternate hypothesis. This is another example. In this example, the average calcium intake for adult is specified. According to the standards, recommended figure is 1000 milligram for a per day for a standard recommendation. But what we are interested here, the average will be, which is described in the null hypothesis, that should be, this is the standard figure, the mean intake of RAI is 1000 milligram, 1000 mg. And alternate will be what? Alternate will be what? In which the researcher is interested. The researcher is claiming that the persons with the low income, with an income below the poverty level, the poor peoples. The researcher is claiming that the, the intake is less than 1000 milligram in the poor peoples. So H1 will be what? H1 will be H1 mu is less than 1000 milligram. This is our alternate hypothesis. Now we have to take a sample from this population, and sample mean is to be calculated, and entire procedure of hypothesis testing is to be performed. In the result of this procedure, we have to decide whether H naught is true or H1 is true. So this is to be completed, but here we have to just write down the null hypothesis in this problem. We have to write down the alternate hypothesis in this problem, and then we have to decide whether two tail, left tail, or right tail. So as we have a less than sign in alternate hypothesis, we should have to use a left tail test here. This is the situation. Alpha, which is the level of significance, is to be used on the left side, and 1 minus alpha, which is the confidence level, is to be used on the right side. This is the hypothesis in this problem. Now, to complete this problem, what we have to do? The entire population we do not have. If we have an entire population, then we have to conduct the census, and by census we can do this problem to check whether H naught is true or H1 is true. But that is not the case, because this problem will not be handled by inferential. In inferential, we have to select a random sample. This is my population. I have to select a random sample of suppose 30 elements. Suppose these are the calcium intakes from this population of selected sample. So these are the sample, and if I have computed X bar, which is the sample mean, and we have to apply a procedure. So there may be an error, because I am going to take a decision about the population parameter without using the entire population. So there may be some error. That error we have to focus here. That error is referred to as level of significance. So alpha is what? Alpha is a type 1 error and the type 2 error. These are the two types of error that may exist in the solution of hypothesis testing. Why these errors may occur in the procedure of hypothesis testing? The reason is we are not going to take the decision by using the entire population. We are taking the decision by just observing a sample. So there is a chance of getting an incorrect decisions. What that decisions are? Probability, there is a possibility that rejecting the null hypothesis, in fact, it is true. There is a possibility that in reality, the H naught is true. In reality, the peoples are taking the 1000 milligram of calcium, but as I was taking the decision by just only 30 observations, so there is a possibility that I rejected the null hypothesis. So rejected a true hypothesis is a type 1 error. Rejecting a null hypothesis which is true. So what is true? The true is people who are poor are taking 1000 milligram of calcium. This is true. But as I took a sample from the poor people, according to that sample, I rejected my null hypothesis. and accepted the alternate hypothesis. What the alternate hypothesis? We are saying that the average calcium intake is less than 1000 milligram. So that is an incorrect decision. That incorrect decision falls under the heading of type 1 error. To reject alpha is what? Alpha is the probability of rejecting H naught, rejecting H naught. Given that it is a conditional probability, given that H naught is true. H naught is true. This probability is known as probability of type 1 error. I am erasing few things from here like this and this so that it should be clear. Alpha is what? Alpha is the probability of rejecting H naught given that H naught is true. And beta is what? Beta is the probability of type 2 error. Another type of error is beta. So beta is equal to probability of accepting H naught, In fact, H naught is false. There is a chance. In fact, H naught is false. H naught is false means H1 is true. H naught is false. This is beta. So alpha is the probability of type 1 error. Beta is the probability of... These are the two types of errors. In the example of calcium, people are actually taking less than 1000 milligram. The H naught is false. H naught is false means what? Actually, in fact, people are taking the less calcium, but our procedure, because it is based on a sample, we have accepted the null hypothesis. Means we are assuming that the people are taking the 1000 milligram, they are safe. But actually they are not taking. They are taking less calcium. So that probability is known as beta. So we can see the type 1 and type 2 error by this statement here. We are saying that the H naught is true. In fact, H naught is false. H naught is true means people are taking 1000 and people are not taking 1000. H naught is false means what? People are not taking 1000. And do not reject H naught decisions and reject H naught. So if the hypothesis is true and we do not reject H naught, it means we accepted the H naught. Our decision is correct. This is the correct decision. No error it is. If the H naught is false, we reject H naught. So it is again a correct decision. So these two are the correct decisions. And these two are the type 1 and type 2 error. This is alpha. Probability of type 1 error is alpha. And probability of type 2 error is beta as defined on the previous slide. So these two types of error may exist in the procedure of hypothesis testing. Probability of type 1 error is known as significance level, and it is represented by alpha. Alpha is what? Alpha is the probability of type 1 error. We generally use alpha in our problem solutions because alpha is very important for taking the decisions in hypothesis. Probability alpha is equal to probability of rejecting H naught, in fact, or given that. Prior knowledge is what? Prior knowledge is H naught is true. So we have rejected a true hypothesis. This is alpha, which is a type 1 error. We generally fix the value, different values of alpha. If it is not provided in the problem, we generally have a moderate value of 5%. But we may have 1% alpha, we may have 10% alpha, we may have other values of alpha. So these are the different values of alpha which we generally used in the procedure of hypothesis testing. We have to fix the value of alpha. We may estimate this alpha in some problems. So there are some problems that we will do to estimate the different values of alpha. These are the possible conclusions in hypothesis test. If the null hypothesis is rejected, we conclude that the data provides sufficient evidence to support the alternate hypothesis. Okay, we will not use the term rejecting the null hypothesis. We use the term data provides sufficient evidence to support the alternate hypothesis. If the null hypothesis is not rejected, we conclude that data do not provide sufficient evidence to support the alternate hypothesis. Instead of using the term rejecting, we use not supporting. Not supporting. Data provide. Null hypothesis is generally assumed and may be example like a court trial. In a court trial, whenever the person is under trial, so we use the term the person is innocent. Person is innocent. This is assumed. Person is innocent. And alternate hypothesis what? Person is guilty. H1. H1 is person is guilty. So if the null hypothesis is not true, so we will not say that the person is guilty. We say that the data evidences does not prove the person is innocent. We use the term evidences. Evidences are what? Data. In the case of statistics, evidences are our data. Our data does not support the H0, or if the null hypothesis is rejected, so we can use the term data does not support H0. So we use the term does not support instead of using rejecting. So these are just terminology and writing conclusions in a standard format.